AI, regulatory intelligence in real life sciences. From information overload to strategic control, introduction, regulation as a battlefield of power. The modern life sciences industries operates in a domain where regulation is not a passive constraint but an active battlefield. Pharmaceutical firms, biotechnology companies, and medical device manufacturers are not merely competing on scientific innovation or capital efficiency, they are competing on their ability to interpret, anticipate, and respond to regulatory change faster and more effectively than their rivals. In this environment, regulatory intelligence is no longer a back office compliance function, it is a strategic capability that determines who enters the market first, who avoids costly delays, and who ultimately dominates. Artificial intelligence has emerged as a critical instrument in this transformation. AI regulatory intelligence systems do not simply automate tasks, they restructure how organizations perceive, and act upon regulatory information. They convert a chaotic and overwhelming stream of global updates into structural, actionable insight. The result is a shift from reactive compliance to proactive control. Organizations that fail to adopt such a system are not merely inefficient, they are structurally disadvantaged. The scale of the problem: information overload and signal loss. The regulatory environment in life sciences has expanded at a rate that exceeds human processing capacity. Regulatory authorities across the globe, ranging from the US Food and Drug Administration (FDA) to the European Medicines Agency (EMA), Medicines and Healthcare Products Regulatory Agency (MHRA), and numerous national agencies, produce an ever-increasing volume of guidance documents, policy updates, and compliance requirements. The growth isn't linear, it is exponential in both volumes and complexity. Companies must monitor updates from over 100 jurisdictions, each with its own regulatory framework, language, and enforcement priorities. These updates span clinical trial protocols, manufacturing standards, labeling requirements, pharmacovigilance obligations, and post-market surveillance rules. The result is a constant stream of information that can easily reach thousands of updates annually. The fundamental problem is not the absence of information, but the inability to extract meaningful signals from the noise. Human analysts are forced to sift through vast amounts of irrelevant and redundant data, increasing the probability of missing critical changes. This creates blind spots that can lead to compliance failures, delayed approvals, and financial losses. In such an environment, attention becomes a scarce resource, and manual systems collapse under the weight of complexity. Traditional regulatory intelligence, structural inefficiency. Before the integration of artificial intelligence, regulatory intelligence relied heavily on manual processes. Analysts spent hours each week searching for updates across multiple sources, compiling reports, and consulting subject matter experts to interpret the implications of regulatory changes. This workflow was inherently inefficient and prone to error. Manual systems suffer from several structural weaknesses. First, they are time intensive. Analysts must dedicate significant portions of their work week to data collection rather than analysis or decision making. Second, they are fragmented. Information is often stored in spreadsheets, emails, or isolated databases, making it difficult to achieve a comprehensive view of regulatory developments. Third, they are reactive. Updates are identified and processed after they occur, leaving little room for proactive strategy. These inefficiencies have direct consequences. Delayed awareness of regulatory challenges can lead to missed deadlines, non-compliance, and product recalls. The lack of integration across teams results in poor coordination, while critical information fails to reach decision makers in time. Ultimately, traditional regulatory intelligence systems can create a lag between information and action, a lag that competitors can exploit. AI regulatory intelligence involves the use of machine learning algorithms, natural learning and language processes, and data integration tools to monitor, analyze, and interpret regulatory information. These systems continuously scan a wide range of sources, including regulatory agency websites, specific publications, digital communications, etc. They identify relevant updates, classify them according to predetermined criteria, and generate summaries that highlight key implications. The result is a shift from data accumulation to Intelligence generation. Instead of presenting raw information, AI systems provide curated insights tailored to the specific needs of an organization. This allows regulatory professionals to focus on high value activities such as strategic planning, risk assessment, and decision making. Core functional capabilities of AI systems. The effectiveness of AI regulatory intelligence systems lies in the ability to perform several critical functions simultaneously. One of the most important is filtering. Given the sheer volume of regulatory updates, the system must be distinguished between relevant and irrelevant information. Advanced algorithms analyze the content of documents and compare them to predefined criteria, ensuring that only pertinent updates are presented to users. Another key capability is categorization. Regulatory information is complex and multidimensional, spanning different therapeutic areas, geographic regions, and stages of the product lifecycle. AI systems classify updates according to these dimensions, enabling users to quickly identify challenges that affect specific products or markets. Summarization is equally critical. Regulatory documents are often lengthy and technical. Summarization is equally critical. Regulatory documents are often lengthy and critical, requiring significant time to interpret. AI powered summarization tools extract the most important information and present it in a concise format. This reduces cognitive load and accelerates decision making. Finally, AI systems provide contextualization. This involves linking regulatory updates to specific business processes, products, or strategic objectives. By doing so, the system transforms abstract information into actionable insights. Instead of asking what has changed, organizations can focus on what does this mean for us. From intelligence to action, closing the loop. One of the most significant advantages of AI regulatory intelligence is its ability to bridge the gap between information and action. Traditional systems often fail at this stage, generating reports that do not translate into concrete decisions. AI systems address this problem by integrating intelligence directly into operational workflows. When a relevant regulatory update is identified, the system can automatically trigger alerts, assign tasks, and initiate impact assessments. For example, a change in labeling requirements might generate a task for regulatory affairs teams to update product documentation while simultaneously notifying marketing and legal departments. This creates a coordinated response that reduces delays and minimizes risks. The integration of intelligence into workflows also enables continuous feedback. Organizations can track how regulatory updates are processed, measures the effectiveness of their responses, and redefine their strategies over time. This creates a dynamic system that evolves within the regulatory environment rather than reacting to it. Strategic implications: speed, visibility, and control. The adoption of AI regulatory intelligence has profound strategic implications. The most immediate is speed. By automating data collection analysis, organizations can identify regulatory changes in near real time. This allows them to act before competitors, gaining a first mover advantage. In highly regulated markets, another critical implication is enhanced visibility. AI systems provide a comprehensive view of the regulatory landscape, enabling organizations to identify trends and anticipate future developments. This shift this shifts the focus from short-term compliance to long-term strategy. Companies can align their research and development efforts with emerging regulatory priorities, reducing the risk of investment in non-viable products. Control is the ultimate outcome. By managing the flow of regulatory information, organizations can influence how quickly and effectively they respond to change. This control extends beyond compliance to encompass market positioning, resource allocation, and competitive strategies. In a sense, regulatory intelligence becomes a level of power, shaping the trajectory of the organization. Implementation framework: building a functional system. Developing an AI regulatory intelligence capability requires a structural approach. The process begins with defining the scope. Organizations must identify which regulatory domains, geographic regions, and product categories are most relevant to their operations. This ensures that the system focuses on high priority areas rather than attempting to monitor everything indiscriminately. The next step is assembling the data sources. This includes both external sources such as regulatory agency publications and internal sources such as company documents and historical data. AI systems rely on comprehensive inputs to generate accurate insights, making this step critical. Curation and validation follow. While AI system can process large volumes of data, human oversight remains essential. Regulatory professionals must review the outputs of the system, ensuring that they are accurate and contextually relevant. This hybrid approach combines the speed of AI with the judgment of human experts. Integration with workflow is the final step. Intelligence must be linked to specific actions with clear ownership and accountability. Without this integration, even the most advanced AI system will fail to deliver value. Common failure points where system collapses. Despite their potential, AI regulatory intelligence systems are not immune to failure. One of the most common issues is the generation of irrelevant alerts. If the system is not properly calibrated, it may produce extensive and excessive notifications, overwhelming users and reducing trust in the system. This reintroduces the problem of information overload in a different form. Another critical failure point is the absence of action linkage. Intelligence that doesn't lead to concrete actions is effectively useless. Organizations must ensure that every regulatory update is connected to a specific response, whether it involves updating documentation, modifying processes, or conducting further analysis. Siloed implementation is another risk. If different departments use different systems or fail to share information, the organization loses the benefits of coordination. Regulatory intelligence must be integrated across functions, including research and development, quality assurance, legal, and commercial terms. Finally, the lack of auditability can create compliance risks. Regulatory environments require traceability, while organizations must demonstrate how they identified and responded to changes. AI systems must maintain detailed records of their processes, ensuring that decisions can be justified during audits. The role of human judgment, limits of automation. While AI systems offer significant advantage, they are not a substitute for human judgment. Regulatory environments are complex and often involve ambiguous or evolving standards. AI algorithms can identify patterns and extract information, but they cannot fully interpret the strategic implications of regulatory changes. Human expertise remains essential for tasks such as risk assessment, stakeholder communication, and strategic decision making. Regulatory professionals must evaluate the outputs of AI systems considering factors such as organizational priorities, market conditions, and long term objectives. This creates a symbiotic relationship between humans and machines, where each complements the strength of the other. The challenge lies in maintaining this balance. Over reliance on AI can lead to complacency, where users accept outputs without critical evaluation. Conversely, excessive skepticism can undermine the efficiency gains provided by automation. Organizations must develop governance frameworks that define the roles and responsibilities of both AI systems and human actors. Competitive dynamics, regulation as strategy. In highly regulated industries, compliance is often viewed as a soft center. However, AI regulatory intelligence reframes it as a strategic asset. By understanding and anticipating regulatory changes, organizations can shape their strategies to align with emerging trends. This allows them to enter markets earlier, secure approval faster, differentiate themselves from competitors. For example, early detection of changes in clinical trial requirements can enable companies to adjust their study designs before competitors are even aware of the shift. Similarly, insights into evolving manufacturing standards can inform investments in new technologies, ensuring compliance while improving efficiency. This creates a feedback loop where regulatory intelligence informs strategy and strategy influences how regulatory intelligence is used. Organizations that master this loop gain a significant advantage, while those who treat compliance as a reactive function remain vulnerable. Economic impact, cost reduction, and resource allocation. The economic implications of AI regulatory intelligence are substantial. By automating manual processes, organizations can reduce their time and resources required for regulatory monitoring and analysis. This translates into direct cost savings, which can be reinvested in higher value activities such as research and development or market expansion. More importantly, AI systems enable more efficient resource allocation. By identifying the most relevant regulatory changes, organizations can prioritize their efforts and avoid wasting resources on low impact tasks. This increases overall productivity and enhances their organizational ability to respond to change. However, these benefits are not automatic. They depend on the effective implementation and integration of AI systems. Poorly designed systems can create additional costs, such as the need for manual correction or the risk of compliance failures. Organizations must therefore approach AI adoption with a clear understanding of both its potential and its limitations. Future outlook. The trajectory of regulatory environments such as the complexity will continue to increase. Advantages in technology, improving healthcare, and global interconnectivity are driving factors in the development of new regulations at an unprecedented pace. This trend is unlikely to reverse. As complexity grows, the dependence on AI regulatory intelligence will intensify. Organizations will need more advanced systems capable of handling larger volumes of data, identifying subtle patterns, and providing deeper insights. The integration of AI with other technologies such as predictive analytics and simulation models may further enhance its capabilities. At the same time, regulatory authorities are becoming more sophisticated in their use of data and technology. This creates a dynamic environment where both regulators and the regulated entities are leveraging AI to achieve their objectives. The result is an ongoing escalation in the use of technology as a tool of control and competition. Conclusion. From compliance to dominance, AI regulatory intelligence represents a fundamental shift in which organizations interact with regulatory environments. It transforms compliance from a reactive obligation into a proactive strategy. By automating the collection and analysis of regulatory information, it enables organizations to operate with great speed, visibility, and control. The implications extend beyond efficiency. In a landscape where regulatory change is constant and unpredictable, the ability to manage information effectively becomes a source of competitive advantage. Organizations that adopt AI regulatory intelligence systems position themselves to lead, while those who rely on traditional methods risk falling behind. The transition isn't optional, it is a structural necessity driven by the increasing complexity of a regulatory environment. As the volume of information continues to grow, the gap between those who can process it and those who cannot will widen. In this context, AI regulatory intelligence is not merely a tool, it is the infrastructure upon which future success in life sciences will be built. AI regulatory intelligence in life sciences continued. Data architectures, the hidden backbone of control. AI regulatory intelligence systems are only as effective as the data architecture supporting them. Most organizations underestimate this layer instead they focus on surface level tools. This is a mistake. The real leverage doesn't come from dashboard or alerts. It comes from how data is structured, stored, and made accessible across the organizations. AI regulatory intelligence systems are only as effective as the data architecture supporting them. Most organizations underestimate this layer, instead focus on surface level tools. This is a mistake. The real leverage doesn't come from dashboards or alerts. It comes from how data is structured, stored, and made accessible across the organization. Regulatory data is inherently unstructured. It exists in PDF, web pages, emails, scientific publications, and legal documents. Without a system to normalize this data into a consistent format, AI models cannot operate effectively. This is where data pipelines become critical. These pipelines ingest raw data, clean it, tag it, and convert it to machine readable formats. Let's talk about a failure point. If your data ingestion is weak, every downstream becomes noise. You will end up looking more unsophisticated and fundamentally unreliable. Organizations that dominate this space invest heavily in metadata frameworks. Each document is tagged with attributes such as jurisdiction, therapeutic area, product relevance, and regulatory stage. Natural language processing and extracting meaning from complexity. Regulatory language is dense, technical, and often ambiguous. Standard keyword-based search systems fail because they cannot capture context. AI regulatory intelligence relies on natural language processes (NPL) to overcome this limitation. NPL models analyze the semantics of regulatory documents, identifying relationships between concepts rather than simply matching words. For example, a regulatory update might not explicitly state that it affects a specific product category, but the language used may imply it. NPL systems can detect these implications and flag them for review. This capability isn't optional. Without semantic understanding, second order effects are often missed. However, NPL introduces its own risks. Models trained on generic datasets may misinterpret domain specific language. This is why domain specific training is critical. Organizations that rely on generic AI tools without customization introduces systematic errors due to decision making processes. Predictive intelligence, moving beyond reaction. Most organizations stop at monitoring and analysis. This is a defensive posture. The real advantage emerges when AI systems are used for prediction. Predictive regulatory intelligence involves analyzing historical data and identifying patterns that indicate future regulatory changes. For example, if multiple agencies begin issuing guidance on specific technology, it may signal an upcoming wave of regulation. Organizations that detect these patterns early can adjust their strategies before formal rules are established. This is where the second order thinking becomes essential. It is not enough to know what has changed, but one must anticipate what will change next. Workflow integrations, where most systems fail. The majority of AI regulation intelligence implementations fail at the integration stage. Without this mapping, intelligence becomes passive. It sits in dashboards or reports disconnected from action. This is not a technology failure, it is a management failure. Organizations that succeed treat regulatory intelligence as an operational system, not an analytical tool. They embed it with daily workflows, ensuring that every relevant update leads to a defined action. Structural design, power concentration versus fragmentation. The structure of the organization determines how effectively regulatory intelligence is used. Fragmented organizations, where different departments operate independently, are inherently disadvantaged. Information flows slowly, coordination is weak, decisions are inconsistent. AI regulatory intelligence systems can either reinforce or mitigate this fragmentation. If each department uses its own systems, fragmentation increases. If a centralized system is implemented, it creates a unified view of regulatory information. Centralization introduces its own risks, such as bottlenecks, over-reliance on a single team. However, these risks are manageable compared to the inefficiencies of fragmentation. The optimal structure is a hybrid model. A centralized intelligence function manages data and analysis, while decentralized teams execute actions. This creates a balance between control and flexibility. Risk management, compliance as a probabilistic system. Regulatory compliance is often treated as a binary outcome. Either you comply or you do not. This is an oversimplification. In reality, compliance is probabilistic. There is always risk of missing a requirement, misinterpreting a regulation, or failing to implement changes correctively. As regulatory challenges, as regulatory intelligence systems reduces the risk by increasing coverage and accuracy, however, they do not eliminate it. Organizations must therefore adopt a risk-based approach to compliance. This involves prioritizing regulatory changes based on their potential impact and likelihood. High impact changes require immediate attention and rigorous validation, while low impact changes can be processed with less urgency. AI systems can support this prioritization by scoring regulatory updates according to predefined criteria. This allows organizations to allocate resources more effectively and reduce the probability of critical failures. Failure point, treating all regulatory updates as equal, leads to resource misallocation and increased risk. Competitive advantage, regulation as a barrier to entry. Many industries, regulation is seen as a barrier to entry. AI regulatory intelligence allows organizations to turn this barrier into a competitive advantage. By mastering regulatory complexity, companies can create barriers that are difficult for competitors to overcome. Similar firms or new entrants may lack the resources to implement advanced intelligence systems, putting them at a disadvantage. This creates a form of strategic insulation. Organizations that control regulatory intelligence can operate more efficiently, respond faster to changes, and exploit opportunities that others cannot see. However, this advantage isn't permanent. As AI tools become more accessible, the baseline level of capability will increase. Organizations must therefore continuously refine their systems to maintain the edge. Ethical and governance considerations. Control versus accountability. The use of AI in regulatory intelligence raises ethical and governance issues. These systems influence decisions that can affect patient safety, product availability, and market dynamics. As such, they must be transparent and accountable. One key concern is traceability. Organizations must be seen to explain how regulatory decision was made, including the data and algorithms used. This is particularly important during audits and investigations. Another concern is bias. AI systems may prioritize certain types of information or interpret data in ways that reflect their training. This can lead to systematic errors if not properly managed. Governance frameworks must therefore be established to oversee the use of AI. This includes definitive roles and responsibilities, implementing validation processes, and ensuring compliance with regulatory requirements. The future trajectory escalation of complexity. The regulatory environment isn't stabilizing, it is becoming more complex. Advances in areas such as gene therapy, artificial intelligence in healthcare, and personalized medicine are creating new regulatory challenges. At the same time, geopolitical factors are influencing regulation. Different regions are adopting divergent approaches, creating additional complexity for global organizations. This fragmentation creates the burden of compliance and the need for sophisticated intelligence systems. AI regulatory intelligence will evolve in response to these challenges. Future systems will likely incorporate more advanced analytics, real-time data integration, future predictive capabilities. This may also become more autonomous. This may also become more autonomous, reducing the need for human intervention. However, this evolution will not eliminate the need for human oversight. As systems become more complex, the consequences of errors increase. Organizations must therefore balance automation with control. Conclusion: structural reality and outcome projection. We are dealing with a system where information volumes exceed human capacity. The response is either structural adaptation or systematic failure. If no middle ground is reached, AI regulatory intelligence is not an enhancement. It is a replacement for outdated operating models. Organizations must adopt it effectively, gain speed, visibility, and control. Those that do not remain trapped in manual processes, exposed to risk and inefficiencies. If the current trajectory, fragmented attention, inconsistent execution, and reactive behavior remains unchanged, the outcome is predictable. We become slower, less accurate, and increasingly irrelevant in environments where precision and timing matters a lot. If system is adopted and executed properly, the outcome shifts. We reduce uncertainty, control information flow, and position ourselves ahead of competitors who are still operating under constraints. Most organizations misunderstand where the value is created. They assume value lies in correcting information or generating reports. That is incorrect. Value is created at decision layer. AI regulatory intelligence only matters if it improves decision quality under uncertainty. Regulatory decisions are not deterministic. They involve incomplete information, shifting rules, and competing incentives. This places them squarely within decision theory frameworks. Each regulatory update introduces a set of choices: act immediately, delay, ignore, or escalate. The choices carry risks and opportunities. AI systems reduce uncertainty by providing structured information, but they do not eliminate it. The final decision still depends on how an organization evaluates trade-offs. For example, acting early on a regulatory signal may provide a competitive advantage, but it could also lead to unnecessary costs if the signal doesn't materialize into formal regulation. Time is the most critical variable in regulatory environment. The difference between acting early and acting late can determine whether a product succeeds or fails. AI regulatory intelligence compresses time by reducing the lag between information and action. This compression creates a structural advantage. Organizations that act faster can secure approvals earlier. This is not a marginal gain, it is a multiplicative effect that compounds over time. However, time compression introduces its own risks. Acting too quickly without sufficient validation can lead to errors. Organizations must therefore balance speed with accuracy. And lastly, no system is perfect. AI regulatory intelligence systems will produce errors, miss signals, and generate false positives. This critical factor is how the organization responds to these failures. Resilient systems are designed to absorb errors without collapsing. This involves redundancy, validation, and feedback loops. For example, Critical regulatory updates may be reviewed by multiple analysts to ensure accuracy. Feedback mechanisms allow users to correct errors and improve the system over time. Resilience also involves scenario planning. Organizations must anticipate potential failures and develop contingency plans. This includes identifying critical dependencies, assessing potential impacts, and preparing alternative strategies. Exploiting the gap. In competitive environments, advantages often comes from information asymmetry. This occurs when one organization has access to better or more timely information than its competitors. AI regulatory intelligence creates this asymmetry by enabling faster and more accurate processing of regular data. The evolution requires continuous investment. Systems can be updated to reflect changes in regulatory environments, technological advancements, and organizational needs. Data sources must be expanded, algorithms redefined, and workforce optimized. AI regulatory intelligence is a system designed to handle complexity, reduce uncertainty, and improve decision making. It is not optional in environments where regulatory change is constant and impactful. The distinction between success and failures lies in structural arrangements. Organizations that align their data, workflows, incentives, and decision processes with the capabilities of AI systems gain control over their operating environment. Those who do not remain constrained by inefficiency and risk. There is no ambiguity in the outcome. Systems can either scale or collapse. Decisions are either timely or irrelevant. Information is either controlled or overwhelming. We are not choosing whether to adopt AI regulatory intelligence. We are choosing whether to adopt correction, whether to operate within reality or